In this module, you will learn about pH of a basic buffer. Based on its pH value, a buffer solution can be classified as acidic or basic. Generally, a basic buffer is prepared by mixing a weak base and its salt. One very common example of a basic buffer is a mixture of ammonium hydroxide and ammonium chloride. Another example of a basic buffer is a mixture of ammonium hydroxide and ammonium nitrate. Let's now try to understand how the pH of a basic buffer is calculated by considering the example of a mixture of ammonium hydroxide and ammonium chloride. Ammonium hydroxide is a weak base and therefore it dissociates very slightly. On the other hand, ammonium chloride is a salt and therefore it dissociates completely. Ammonium chloride is formed by mixing a weak base and a strong acid. Thus, the mixture contains ammonium hydroxide molecules, ammonium ions, and chloride ions. There exists equilibrium between ammonium hydroxide molecules and ammonium and hydroxide ions. For the equation, the base dissociation constant Kb is equal to concentration of ammonium ions multiplied by concentration of hydroxide ions divided by concentration of ammonium hydroxide. After rearranging, we get concentration of hydroxide ions is equal to Kb multiplied by concentration of ammonium hydroxide divided by concentration of ammonium ions. Taking the negative logarithm on both the sides of the equation, we get minus log of concentration of OH minus ions is equal to minus log of Kb minus log of concentration of ammonium hydroxide divided by concentration of ammonium ions. You know that minus log of OH minus is equal to POH and that minus log of Kb is equal to pKb. By substituting these terms in the earlier equation, we get POH is equal to pKb minus log of concentration of ammonium hydroxide divided by concentration of ammonium ions. We can also represent the equation as POH is equal to pKb plus log of concentration of ammonium ions divided by concentration of ammonium hydroxide. Here, the concentration of ammonium ions is almost equal to the concentration of ammonium chloride. As ammonium chloride is a strong electrolyte, it completely dissociates to give ammonium ions. So, the equation can be written as POH is equal to pKb plus log of concentration of ammonium chloride divided by concentration of ammonium hydroxide. Thus, we can generalize the equation as POH is equal to pKb plus log of concentration of salt divided by concentration of base. This equation is called the Henderson-Hasselbalch equation. Therefore, we can write the Henderson-Hasselbalch equation in terms of pH as pH is equal to 14 minus pKb minus log of concentration of salt divided by concentration of base. If concentration of base is equal to concentration of salt, then POH is equal to pKb. Let's now study the buffer action of a basic buffer consisting of a mixture of ammonium hydroxide and ammonium chloride. If you add a few drops of hydrochloric acid to this mixture, hydrochloric acid, being a strong acid, will release hydrogen ions into the solution. The hydrogen ions react with the hydroxide ions in the mixture to form water molecules. Water does not alter the pH of the resulting solution. Thus, the addition of an acid to a basic buffer does not change its pH. Similarly, if you add a few drops of sodium hydroxide to the mixture, sodium hydroxide, being a strong base, will release hydroxide ions into solution. The hydroxide ions combine with ammonium ions to form ammonium hydroxide. Ammonium hydroxide is a very weak base and does not furnish hydroxide ions to alter the pH. Thus, the addition of a base to a basic buffer also does not change its pH. So, there will be no change in pH. You have now reached the end of this module. In this module, you learned that the pH of a basic buffer is greater than 7. A common example of a basic buffer is a mixture of ammonium hydroxide and ammonium chloride. The pH of a basic buffer is equal to 14 minus pKb minus log of concentration of salt by concentration of base.